Hello, CS202 students, and welcome to this instructional video on Assignment 8, which is going to be your last assignment for the semester. The main focus of this assignment is linked lists, but it is a final project. So, in this assignment, we've included everything that you have learned in this class previously. That is classes, inheritance, virtuals, dynamic memory, operator overloading, templates, and even recursion. Okay? So all that stuff is included in this assignment. You can't get away from it. So please embrace it. Now, the concept for this assignment is not very exciting, but the code itself is very exciting. So bear with me here while I discuss what we are going to do. We are going to be garbage workers. That is, we're going to clean up a pile of garbage. The garbage in this case is a text file. And this text file contains a whole bunch of stuff. And you'll notice that each of these things, though they all could be considered to be strings, you'll notice that they could also be considered to be a different data type. That is, this is a character here, that's a double, that's a boolean, this is an integer, and that's a string. So what we're going to do is we're going to read in this data, and we're going to store it in some garbage pile, and then we're going to sort through the garbage. So that we can see where everything is and how much of everything that we have. Now, that garbage pile is a linked list. And the nodes within that linked list are of all of these different types. And that's kind of the interesting part about this assignment, is that we have a linked list in which nodes of different types are linked to each other. We may have, in this case, a character linked to a string, to a character, to a double, to a character, to a bool, to a bool, to a bool, to an int. In the linked list that you've probably studied in class, you're probably used to something like this, where you have some struct called node, and within that node you have some data. It might be a template type, or it might be an integer, or a string, or whatever. And then you've got your next and previous nodes, like that, and like that. Now, the thing to note here about this struct is that it can only hold integers. That is, your whole linked list can only be integers, nothing else. But in this assignment, our linked list will be of any of these 5 types here. So let's go ahead and take a look at what we've got going on here in the classes. And actually, before we do that, let's talk about the data types. We have to establish a precedence. That is, if you look here in this file, I'm going to go ahead and type out 1. All of this garbage, they could be considered a bunch of different types. That is, this 1 here specifically, that can be an integer, it could also be a character, it could also be a double, and it could also be a string. Now, if we weren't representing bools with true or false, this 1 could also be considered a boolean. So we're going to ask ourselves, what type is that? That is, what's our priority of types? Well, that's established here in the PDF. That is, everything will be checked to see if it's an integer first. If it's not an integer, then we'll check to see if it's a character, then if it's a double, if it's a bool, or then if it's a string. All right. So let's take a few examples here. If we look at 1, that's obviously an integer. So we'll take it, and that's what it is. Next, maybe we'll check this p. That is not an integer, so we'll check to see if it's a character. It is a character. We'll take it. We're good. Let's look at this one here. We'll check to see if that's an int. It is not. Is it a char? It is not. Is it a double? Yes, it is. We'll take it. We'll stop there. We'll look here. Is this an int? No. Char? No. Double? No. Is it a bool? Yes. We'll take it, and then we'll stop. And then finally, with these, we'll check to see if it's an int, a char, a double, and a bool. All will return false, and we'll finally determine that this has to be a string. Okay, so that's what the precedence is. You'll notice that they're organized in this way and in this way. Okay. Now, we have got 3 classes going on in here. We've got the data element base class, we've got the data element class, and we've got the garbage pile class. Now, definitely work your way top down here. That is, get started on this class, and don't move on until you've got this one working. because this garbage pile class relies heavily on this data element base class. Now this data element base and data element, the set of classes is an inheritance, in which the data element, which is a template type, inherits from the data element base class. Now this base class is also abstract. That is, you cannot instantiate objects of this class. You'll notice that we've got quite a few virtuals in here. 3 of them. 2 of them are pure virtuals. So you cannot actually just have a data element base object. You have to have objects of the data element. But we will be using this as a base pointer to store our data element base, our data elements, okay? So our linked list will actually be made up of these data element base pointers. If you would like to reference what you're used to, the data element base and data element combo are basically that struct right there, the node struct. There's some method there to store the data. There's some data that's stored within that node, and there's also a next and a previous pointer. But there's so much more involved with these nodes. There's so much more involved. But you'll notice here there's the next and the previous pointers. And you'll notice that the data is actually stored down here in the inherited class. So all of the pieces for a linked list node are there. You just need to know how to navigate these 2 classes. So let's go ahead and get started looking at that. So to begin, we have a data type. This is an unsigned short, and you can see all of the data types up here. Okay, this is just to make your life easy, in that you can just directly type out these, and it will replace this kind of string here. It will replace that name with whatever this value is. Okay. Instructor Black would explain that as an enumerator type-ish thing. All right, so when you are creating your data element bases, you're going to have to store what data type is in those nodes. So for example, we might be storing a string. You're going to want to store the literal up here string, that is 4, into that member variable. So you could probably just say something like data type is equal to string. That's what those are meant to be used for. Okay. That is what this element corresponds to. That is, our node is a string, int, double bool, or whatever one I missed. Obviously, next we've got our next and previous pointers. That is for our linked list. We need those. And then we'll come into the constructors here. We've got a data element base. This constructor is only going to initialize the data type to be whatever was passed into here. That is, this is going to be a string, so make sure we recognize that. Now, because this class has some pointers in it, we need some rule of 3 stuff going on here. Now, this is not the traditional rule of 3 implementation you would consider, because these are actually the next and previous pointers. And they're likely going to be deallocated by the garbage pile class. So within the destructor, you actually don't have to worry about deallocating these. But when it comes to these 2 things here, that is the copy constructor and the assignment operator overload, you have to make sure that you're not making shallow copies of those pointers, right? Because if you were to make shallow copies of those, you would end up attempting to link whatever the new element was into the list. In fact, it would look like this. Now you'll notice that this green one down here, this is what we made a copy of, or that is the copy. We made a copy of the blue element, and that is our green element here. Now, assuming we didn't actually include overloads, like that assignment operator overload, and include the copy constructor, we would be making shallow copies of that next and previous pointer. And you'll notice that it will attempt to link itself into this list, but it's not really doing anything there, as this previous node has no way to get to it, and this next node here has no way to get to it. So the whole purpose of including those rule of three things, specifically these two, is to not link it into whatever list you're copying from. In this case, you're just going to make sure that the next and previous nodes are null. And in this case, you're going to make sure that you don't touch them. That is, the object may already be linked into a list and you don't want to take it out. We've got a virtual destructor here. This is required in order to properly deallocate data that is stored in this derived class. Now, it turns out if you store integers or any other primitive type in here, you're not going to have memory leaks. But if you store like a string in here or some other object of a class that has a pointer associated with it, if this destructor were not virtual, you would get memory leaks here because the destructor for the string would be skipped. So this needs to exist. It has to be virtual. There is no code associated with this. All right, it's just there to be there to prevent memory leaks. Here we've got our two virtual functions. They're pure virtuals. That is, both of these are overridden down here in the derived class. And they're very important, especially this getData. Now, the type of this getData function is a void pointer. That is, it just returns an address, some address. That's all it returns. And we don't know what the type of that address is. Now, in a traditional linked list, a getData function would return whatever type it is you're working with. That is, if the linked list is of integers, you're obviously going to return an integer from this function. Because in this linked list, we don't exactly know what type of data we're going to get out of the node, we cannot specify the return type for that function. Hence, we are returning a void pointer, just some address. Now, with that void pointer, we can reference the data type of this node, and then we can cast it to the appropriate type pointer, and then dereference it. So for example, if we were going to store an integer here, we would call getData and store the address to that integer. We would then check to make sure that this class is an integer, or this object is an integer. And if it is, then we will cast this void pointer to an integer pointer. And once we've done that, we can then dereference it to extract the data from that address. Similarly, if it were a string, we would cast it to a string pointer, dereference it to get the data that's being stored there. So that's a very important one. It's important that you know how that works. We've got another virtual here called print element. This is just an easy one. It's only there so that we can see the data that's being stored there. It has to be virtual because the data is being stored in the derived class. If you want to see the data that's being stored there, you have to go down here to the derived class. Hence, this is virtual. Now we've got three getters. These two getters here are necessary because the next and the previous pointers are private. So if you're looking to traverse your linked list, you have to do it through these getter functions. If you'd like to see what type the object is, you've got your getDataType function. Here we've got a link function. This is very important because, once again, you do not have access. Well, you kind of do, but you don't have direct access to these pointers. That is, you can read what they are, but you're not allowed to overwrite them. So we've included this link function that's going to link a new node into the list. It's a handy dandy little function. Highly recommend using this, otherwise your code won't work. Next thing we've got here is a compare function. Now, I wanted to make this an operator less than, but I was unsuccessful. You do not have to implement the code for this one, but you will be using it when sorting your list. So you'll notice that this instanced function is taking a data element based pointer, and it's going to compare the contents of this object with the parameter object. You notice it returns a short, and it's returning one of these. So if it happens to be less than the parameter, you'll return a less than. If it's greater than, you'll return that, and if it's equal, you'll return that. You'll have to use this in your sorting function. So you'll call compare, and then you'll check to see if it's less than, greater than, or whatever, and then you'll make your swap based on the result of that. Now, these two are very helpful and very fun functions. You are going to need them as well. This first one here is get new data element. Now, you'll notice it returns a pointer to a data element base. The way this is intended to be used is that you will read in some garbage, such as this 5.78. You will determine that this 5.78 is a double. Once you've determined it's a double, you will pass that as the unsigned integer there. You will say, hey, this object is a double. And then next, you will actually pass the string. That is, you're going to be reading in all of these as strings to begin with. And then you'll make the conversion later. So you'll read this in as a string, and you will pass that string to this getNewData element. What this function will do is it will allocate memory for a data element down here of the proper type, and it will initialize it so that the data type is correct and that the data down here is holding whatever that string was of the proper type. That is, it will be holding 5.78 in double form. This one is very similar to the one above, except this one is not going to make a new element from the raw parameters. Rather, it's going to make a copy, a deep copy of a node that already exists. So in this case, you're going to have some node here, and you have to make a deep copy of it. So this one will do almost exactly the same thing as the one above, except how do I initialize it? Well, I have to grab both the data type and whatever the data is from this parameter object. This one's a little bit tricky because in here you're going to have to call that void function, that void pointer function getData. You're then going to have to cast that data up to the appropriate type, and then you will have to allocate a new data element of the appropriate type. Finally, we have our swap function. You'll need this for the sorting function. Now, in this swap function, you have to manipulate only the pointers. I was kind of evil here, and there's no way to shorthand this in that in a kind of a traditional swap function, you might just take one data out of a node and put it in the next node. That's kind of a lazy way of doing it, and it can be very inefficient depending on the size of your data. So we want to make sure that you know how to swap the pointers around in a linked list to simulate an actual element swap. Now, because we're storing elements of different types, there's no way you could assign an integer to a string. Maybe there is, but for the purpose of this assignment, there's no way to do that. Similarly, there's no way to store a string object into an integer object. So you literally cannot move data from node to node because the nodes are of different types. So you can't shortcut that. You have to swap the pointers. Please read carefully on that. Get some paper, a whiteboard, draw out what the swap looks like before you code it. It's very important that you understand how that works. Because if you're trying to debug your code, it's not going to make very much sense. You're going to be sorting a list of maybe 100 elements. If your swap's not working, it's going to be hard for you to tell what's going on. So definitely get some paper, get a whiteboard, draw it out, make sure you know what's going on there. Now we've got the derived class. As I've said, we've got these two functions here, which are overrides of the two virtuals up here, which are necessary. And it's our template type. We've already implemented this one for you. You don't have to worry about it. Now here we have our garbage pile class. This is very important. This is our linked list object. This is our linked list object. So you'll notice here we've got a head and a tail pointer. And we've got a size. That is, how many elements are we storing in this linked list. Just give me a moment here to get set up. Now, we've got a few constructors, operators, and functions going on in here. To start, we've got a default constructor. We've got a copy constructor, a destructor, and an assignment operator overload, because this garbage pile contains pointers. So in this one, it's pretty traditional implementation in that we have to make a whole deep copy of the linked list. And I do test it. You can't get around that. So in both the copy constructor and the assignment operator overload, you have to make a whole deep copy of the whole list. I highly recommend using this function here. Deep copy data element. It's going to make your life very easy. All right, it's going to make your life super easy. Do a deep copy data element on the parameter object nodes in order to allocate new nodes for your list. Next, we've got the add item. Highly recommend using the get new data element here. That will make it easy for you to add a new piece of garbage to your pile. Here we've got a clear garbage pile. This has to be recursive if you want full points. It's not too hard. And of course, it doesn't have to be recursive in the real world, but we just wanted to make sure that there's some recursive implementation in this assignment. So similar to assignment 7, there is a check in code grade that will find this function, and it will verify that you've made it recursively. Wrapping up here, you've got the sort function. This is just a regular bubble sort. Highly recommend. You're going to have to call swap and compare in here. I also highly recommend calling the bracket operator. This bracket operator is intended to be used like a standard bracket operator on any array. That is, if I want to know what the third piece of garbage in my linked list is, this operator will do that. This is not very efficient at all, but it's an easy way for us to access our elements. Now, that's not it for this class. Those are all the main things, but there are 2 friend functions that are not listed in there. Let's go find them. You have to... I've got to change that. You have to implement these operators here. In fact, they're both friends. I will change that in the PDF. These are both friend operators. Okay? This one is going to output the whole garbage pile. This one is going to read in just a single element and add it to the pile. So you have to include those as well. Now we're almost done. You also have some global helper functions. Most of them are implemented for you. But there is one here called unsigned int get data type. It's there to help you determine what type this garbage string is. So we talked about the precedence rules, right? So we'll check to see if it's an integer, a character, a double, or a bool. And then finally, maybe it is a string. So it will return whatever that is. You are provided the skeleton code here, so let's look at that. Here it is. We provided pretty much everything for you. There's a bunch of stuff up here. But you'll notice where you need to add comments in your code, that's all included in here. There's a few things that are done for you, such as the compare function. Notice that this is a good reference for you if you'd like to understand what's going on here. You'll notice that we are calling getData from a pointer to the base class, and then we are going to cast it to an integer pointer before dereferencing it. We'll also do this with the cars, the doubles, the bools, and the strings. So you've got all that stuff in there, and all you have to do is fill it in. So let's go ahead and do just some example runs. Now the code grade is designed to give you as many points as possible. That is, there are tons of unit tests. There are 17 total unit tests. So you can kind of test your code individually, but let's go ahead and do the full run. So you can do a compile. I believe there's a make file provided for you, but I'll just compile it like normal here. And you're going to be given some executable file, and then you can run it. In your assignment, it will be called processing, so you might do /processing, and then you will provide it with the garbage text file. And when you run it, you'll notice first it's just going to read everything in and print it all out like normal. You'll notice it prints it in rows of 3. That's just to kind of manage the output. But it will print it all out in rows of 3. And then we'll sort it, and then we'll print it out. You'll notice all the integers are there, characters, doubles, bools, and then strings. So that's the basic run. Now we will provide these unit tests for you to see. They are not labeled, so check the code grade for the labels there if you want to see, or just open them and read them. You'll notice here I'm just going to test your allocation and deallocation of data elements. Here I'm going to test your get data type, and here I'm going to test your get data. Here I'm going to test your print element. Here we're going to test your linkings. We're going to test your links. So there's a whole bunch of tests going on in here. Here we've got garbage pile stuff. So go ahead and look at these and kind of work with them. You can just upload them and compile them yourself. So similar to how I compiled this previous one, I can compile another one. So I will take maybe unit test 0. And I messed up here. Give me 1 second to figure out why that happened. Don't mind me. I made a silly mistake. I have to provide my implementation file, but I have to change the main file. Unit test 0. There we go. Now when you run it, you'll notice that I'm just checking for these things. I also run them with Valgrind. All right, so it's very important that you also check that as well to make sure there are no memory leaks. All heap blocks were freed and there are no invalid reads or writes or uninitialized values or anything like that. So that is the assignment. Similar to assignment 7, of course I exist in your Discord. Of course ask your TAs and your instructors. Sam Black and I both work together on this assignment, so we know all about it. Feel free to ask us questions if you need. Best of luck to you on this assignment. I hope you have a great time, and I will hopefully see you around the university.